Welcome to this video. So what are we doing in this video? We are practicing the questions from dynamics, Newton's laws of motion. Here is a question from your past paper AS Physics. This is your question number 2. Alright, so if you want, you can pause the screen here. Try to attempt the question yourself and play the video to look at the working of it and to look at the mark scheme. Meanwhile, also do not forget to subscribe to the channel, which I keep saying again and again in each of my videos. Why? Because it is highly encouraging for me to see your subscriptions coming, and please do comment in the chat box also to let me know your feedback. Alright, so I believe that you all are now coming back to the video after solving this question. So let us start with the part 1. State Newton's second law. So in the previous question number 1, what did we do? We did the question paper asked about state Newton's first law. This question is asking about state Newton's second law. So what do you understand from this? You understand that you need to practice writing Newton's first law, Newton's second law. Practice it, because these questions keep repeating. As we practice more and more questions on dynamics, you'll see that these are a kind of question which keep repeating year after year. The Newton's first law, second law, third law of motion. Cambridge keeps asking every year, almost every year. So how do you state Newton's second law? If you remember, finally, the summary of Newton's second law says force is equal to ma. What is ma? What is the formula for acceleration? V minus u over time. So if you open the brackets, what do you get? mv minus mu over t. If you just write this formula, write the formula F is equal to ma, open the formula slightly by including the formula for the acceleration and open the brackets. That's your answer. Why? What does this final term here telling you? Force is rate of change of momentum. What is mv? Final momentum. Mu is initial momentum over the time taken for this change in momentum to take place. If you remember, the formula for momentum is mass times velocity, right? This is your answer. Either you write this equation, which is sufficient to get you 1 mark, or you write it in words. Force is rate of change of momentum, right? If you see here, that's what the mark scheme is also saying. Force is equal to the rate of change of momentum. Let us now come to the second part, the B part. A ball of the mass is given. It hits a ball with a velocity. Velocity is given perpendicular to the ball. The ball rebounds perpendicular from the ball with a speed. Contact time of the ball with the wall is also given to you. Calculate for the ball hitting the wall the change in the momentum. So whatever you have written in the first part, the Newton's second law, you are going to apply here. What is the change in the momentum? mv minus mu. Please do remember, you have to identify v and u correctly. V is what? A velocity which comes later point of time. So what is the velocity which you are arriving at a later point of time? 3.7. What was the velocity earlier? It was 5.2. So very important that you identify v and u correctly. If you go through my video on acceleration, you'll understand how to identify v and u correctly. So what is the mass? Mass is also given to you. So 65 times 3.7 minus 65 times 5.2. That's your change in the momentum. Work it out on your calculators and let's see the mark scheme. Your answer should be this: minus 5.8 Newton second. What is the answer? Minus 5.8. Is it 5.8? Am I reading it? 0.58, sorry. Minus 0.58 or minus 0.58 The unit is already given to you, so need not write the unit. 2-mark question, right? Start with writing the formula. Change is always defined, change of anything is always defined as the final value minus the initial value, right? So always subtract the initial value from the final value whenever you have to find the change, be it the change of momentum, change in the speed, change in your weight, change in your height. Always it is the final minus initial. That's the formula for the change itself. Second part, the magnitude of the average force of, if you see, you are just working on this formula. You found the numerator here. You know the time value as well. All you have to do is divide it, your answer here, with T. Numerator you have already calculated. So force is, numerator is already done here. So minus 0.58 divided by time. Time is how much? Take care of the term m here, milliseconds. So which means 7.5 times 10 to the power minus 3. Work it out in your calculators, please. Take some moment, pause the video. So what is your answer? 77.3 newtons. 77.3 newtons. Though the mark scheme is not stressing on continuing with the negative sign, it is not stressing it, but always follow the good practice of retaining whatever signs you are getting. Do not just ignore it, because you might be using this number somewhere again later on in the question. In this question you are not going to use this force value in the later part, because if you read the later part you are not going to use this force value. But if there are some later part of the force or later part of the question where you are required to use this force, then the negative value would make sense. You'll have to use a negative 77 newtons as your answer. So even if you're getting a negative answer, retain it, mention it in your answer. Be confident about it. This is a correct answer. Do not worry. Negative sign doesn't mean that your answer is wrong. If the mark scheme is not stressing on the negative sign, ignore it. If you are getting negative answer, carry on with the negative numbers. Mention your answer as negative numbers. Your examiner will still give you full marks because you're 100% correct. Right? It is a good practice. Please follow it. Do not skip the negative sign. Do not ignore it. Retain it. You never know when in the later part of the question you might use this value and the negative sign here will make sense then. Right? So negative answer, perfectly correct. Do not worry. Let us come to the C part. For the collision in B between the ball and the wall, state how the following applies. So many rhyming words, ball, wall. Okay, state how the following apply. Newton's third law. 2-mark question. Newton's third law talks about equal and opposite force, right? So the force, which is, you can say, Newton's third law. If this is your ball, this is your wall. The force which the ball applies on the wall is equal and opposite to the force which the ball applies on the wall. Equal is a key term, opposite is a key term. So you have two key terms, equal and opposite. Mention both of them to get 2 marks. Force applied by the ball on the wall is equal and opposite to the force applied by the wall on the ball. This should be your answer. I'm saying it, I'm not writing it, but it should make sense, right? If you want me to write everything that I say, please do mention in the comment box. I'll take care of it, that I do write what I say as well. So if you look at the mark scheme, the force on the wall from the ball is equal to the force on the ball from the wall, but in opposite direction. If you're just mentioning the Newton's third law of motion, you just get 1 mark. If you say Newton's third law of motion says that forces exist in pair, they are equal and opposite. If you just mention the third law, you'll not get. You have to apply the third law of motion in this particular concept, and you have to talk in terms of ball and wall, because they are clearly mentioning how the law applies in this particular case which is happening here. So apply here. and tell your reasoning, because this third law is not same as the first question. The first question is telling you to just state the second law, so you state it. But here they are telling you to apply this third law and explain it with respect to this situation. Now the second part, the law of conservation of momentum. In this particular case, how do you explain it? Total momentum before the collision is equal to total momentum after the collision. Say that the momentum of the ball, let me write it again. Momentum of the ball plus momentum of the ball before the collision is equal to momentum of the ball, let's call it after the collision, it's prime, momentum of the ball after the collision. Sum of the total momentum of the ball and wall before the collision is same as sum of the total momentum of the ball and wall after the collision, right? Or this can be also written as minus use your logic of maths and see if these two equations are correct and they are precisely the same. They are precisely the same. You're just picking it and bringing it on this side of the equation. You are picking it and bringing it on the other side of the equation. So what does it mean? The left hand side reads as the change in the momentum of the ball is equal to the change in the momentum of the wall. Either you say that the change in the momentum of the ball is equal to the change in the momentum of the wall, or else you say total momentum of the ball and wall before collision is equal to total momentum of ball and wall after collision. Either you say the first statement or the second statement, your answer is correct. But you have to talk in terms of ball and wall because you have to apply the concept with respect to ball and wall situation which is given in the question. Do not just state the law of conservation of momentum, apply it in this context. Now the last question, I'll show you the mark scheme as well. Here. Momentum change of the ball is equal and opposite to the momentum change of the ball. Change of the momentum of the ball and wall is 0. Okay, so let us understand one more thing. So let us call this thing as change in the momentum of ball, and let us call this thing as the change in the delta. Always means change in the momentum of ball. Now let us take both the things on the same side. I'm sorry, I'll just write it more neater. So change in the momentum of the ball minus change in the momentum of the ball is, if you subtract them, what do you get? Same thing, right? Either you say this way or you say change in the momentum of the ball minus the change in the momentum of the ball is 0. You can talk about the law of conservation of momentum in so many ways. In way 1, way 2 or way 3. Everything is acceptable. This is what the last point says. Change in the momentum of the ball and the wall is 0. This last statement here is same as this here. Change in the momentum of the ball and the ball is 0. Right? So many ways of writing this answer. It's just a 1 mark question here. But we are trying to understand in so many ways, because if later on this question comes as a 4 mark or a 3 mark question, if you understand the theory well, you can write it in more details and gain all the 3 or the 4 marks. Here it is 1 mark. You can just write any one of these as a single statement and get all the 1 mark. But this question can come as a complicated question in some other years. Then you should know, you should be clear on that you can write the law of conservation of momentum in so many other ways as well, and you can pick up any of the ways to describe the situation in that particular question. Alright, now the last point, state with a reason whether the collision is elastic or inelastic. So how do you define elastic and inelastic? In terms of kinetic energy. Is the kinetic energy conserved? For the kinetic energy to be conserved, the velocity has to be conserved. Is the velocity conserved? Compare the two numbers. No. The formula for kinetic energy is half mv square. If the velocity itself is reducing after collision, that means kinetic energy is reducing, right? So it is inelastic. Simple. This is an easy question. Elasticity or inelasticity depends on kinetic energy to be conserved. Read the mark scheme, you should understand it. This is a simple question which is covered in the theory. Elastic means kinetic energy is conserved, which we clearly see is not conserved. It is a case of inelastic collision. So here we are. This is the mark scheme. Go through it, read the mark scheme carefully to understand how it works. In the next question, we'll take up the third question for dynamics. Thank you. Stay connected, please.